Hey class, today we're going to be going over the conversion problems. So you're getting a worksheet, but I wanted to show you a couple of examples that you did in class yesterday and a couple examples today in class to help walk you through how to do conversion problems. So again, we're in chapter 3, section 3, talking about conversion problems going from grams to moles, and then also now moles to number of particles, number of atoms, or number of molecules. So on the screen here, you'll see the problems that we did yesterday in class. How many moles are in 23.5 grams of sulfur? On this next screen, you'll see me working out the problem again. Whenever we do conversion problems, we got 3 steps to follow. Make sure you're committing these to memory. Step 1 is write down what you know. What is given in the question? Question here says, how many moles are in 23.5 grams of sulfur? So when I go to set my problem, look at line A, I would write down 23.5 grams of sulfur because that is what was given to me in my problem. Then step 2, I follow my units. If I have grams of sulfur, I have to go to grams of sulfur in the denominator on the next section or in the conversion problem. Then after that, we go to step 3, get a conversion factor. From your periodic table, looking at the atomic weight or the atomic mass, you need to get this number off of the periodic table. We want to go to 2 decimal places, and then we would set up 1 mole of sulfur equals 32.07 grams of sulfur, because that's what that number means. When we put the units AMU behind it, we're talking about the mass of protons and neutrons. When we put the unit grams behind it, we're talking about the molar mass, how much 1 mole of sulfur weighs. So when I put my equation here together, I go and multiply across the top, divide across the bottom, and I would get the value of 0.73277 moles of sulfur. Since I have 3 sig figs in my answer, I need to go to 3 sig figs in the prop and my answer, so it would actually come out to 0.733 moles of sulfur. There's another video I created talking about diatomic molecules. It's about 3 minutes long. If you need to hear about that again, please check that out on this channel. So a couple other problems I want to show you guys. Going from moles to molecules and molecules to mole. Again, here's another problem we have. How many moles of oxygen are in 2.00 times 10 to the 22 molecules of oxygen? So step 1, I write down the given. What was given to me in the problem? So now we can look at line B. We see 2.00 times 10 to the 22 molecules of O2. Now again, why did I write O2 here? Because oxygen is one of those 7 diatomics that does not exist in nature by itself. He will always bond with himself. So I need to write molecules of O2, write down the complete number and units that they give you in the problem, and then I'm going to go now to step 2. I follow my units. I got molecules of O2 here. I will go to molecules of O2 here. Then we go to step 3. I get a conversion factor, and we see that we can go from number of anything to moles. So I can go 6.22 times 10 to the 23 molecules of O2 to 1 mole of O2. Now remember, this mole equals this value. So if I want to go to dozen, I could say, well, how many dozens is this? I could have put 12 O2, molecules of O2 equals 1 dozen O2. It doesn't matter because this is just a quantity. And then below you can see where I gave you a little cheat sheet reminder of saying that you can always convert from grams to moles or moles to grams. You can always convert from the number of anything, atoms, molecules, FU, anything to moles. And FU stands for formula unit, which we'll talk about when things have an ionic bond. And so this will be useful to recognize here in a little bit. But again, as I put this in on my paper and I begin to put it in my calculator, let's make sure we learn how to do it. So make sure you get a calculator out. The teacher can pause the video if you need time, but get your calculator out and let's practice putting this in our calculator. So first of all, I would have 2.00 in my calculator. Then I'm going to look for a button that says EE on it. Once I hit EE, you should notice that it pops up in the top corner here where it says 00. Once I have that 00, now I can enter in 22 because I'm going to go 2.00 times 10 to the 22. So you should get something that looks like that. Then, since this is in the denominator, I will hit the divide button, and now I will enter in 6.022, find the EE button again, and then hit my 23, and you should get something that looks like that. Hit equal, and I'm going to get a value of 0.003221558. Again, my answer, my original measurement has 3 sig figs, so my answer needs 3 sig figs. And so here again, I wrote it in scientific notation, 3.32 times 10 negative 2 moles of O2. So now let's look at problem C that I have on the line. How many atoms of sodium are in 3.80 moles of sodium? Again, I write down what I know, what's given in the problem. So I have 3.80 moles of sodium. I follow my units, mole of sodium, mole of sodium. Then I know I can go from mole to number of atoms. 1 mole times 6.022 times 1023 atoms of Na. Again, the reason this atoms of sodium is because atoms of sodium can exist by themselves. As I were before, molecules of oxygen exist because oxygen bonds with itself, and since it's a covalent bond, we call this a molecule of oxygen and not just an atom. An atom would be a singular O by itself. Since sodium is by itself, that's what we call it an atom. Again, now my problem's set up. I multiply across the top, I divide across the bottom. So my calculator, practice entering this in, you should get 3.8. Then I'm going to hit times. Then I'm going to hit 6.022. I'm going to find the EE button again. It's different on different calculators, so just make sure you look for it. And then I'm going to hit times 23. It will be in the top. And then I hit equal, and I should get something to that fact. Again, my answer has 3 sig figs. So my measurement in the original has 3 sig figs. So my answer would have 3 sig figs. All right, let's look at 2 more problems. How do we set them up? Here's a problem where I have to have 2 conversion factors. How many molecules of hydrogen are in 0.020 grams of hydrogen? So again, step 1, I write down what's given. 0.02 grams of hydrogen. 0.02 grams of hydrogen. Again, hydrogen is one of the 7 diatomics, so I have to write as H2. And then now I do step 2. I follow my units. Grams of H2, grams of H2. But we notice here that since this is a diatomic, I have to double the mass off my periodic table. On your periodic table, it says hydrogen is 1.01 grams per mole. Well, since it's a diatomic, I have to double that mass to get my conversion factor. Then I do step 3. My conversion factor is 1 mole of H2 equals 2.02 times grams of H2. Now, since I have multiple steps I need to go through, I have to add a second conversion factor. And this is where this will kind of help. This little trend on the bottom. Whenever I have grams, you should know a conversion factor to go from grams to moles. Or if you have moles, you know you can go from moles to grams. If you have the number of something, a number of atoms, number of molecules, number from the units, number of dinosaurs, number of donuts, it doesn't matter. You can always convert that to a mole. Once I have a mole, then I have to convert to grams. So this little roadmap here will show you if you need multiple conversion factors. So here I'm in mole, and I need another conversion factor to get to molecules. So I repeat step 2. I follow my units. Then step 3, I get a conversion factor. I know 1 mole of H2 equals 6.022 times 1023 molecules of H2. Again, I put this in my calculator. Now, how do I put this in my calculator? The best way to do it is to enter in your first number, which is 0.02. Then I go to this. Since the 2.02 is in the denominator, I'm going to hit divide first and then by 2.02. Then when I come to this conversion factor, since the value is in the numerator, I'm going to hit multiply by 6.022, hit the EE button, and then I'll automatically hit in 23, and I'll get something that looks like that on my calculator. That is expressing this value right here. Hit equal, and it'll come up with 5.9623 times 10 to the 21st. Because I got 2 sig figs in my answer, and I got 2 sig figs here, I'm going to round that 5.9 to 6.0. So the key here for this problem is realizing you have to double up the mass and then make sure you enter it in correctly. And my answer would be in molecules of H2O. This is the correct answer. I have to have the complete units and the correct number of the right sig figs to get it right. Then the last problem we have, how many atoms of sodium are in 3.80 moles of sodium? How do I do that? Again, I write down what was given. I follow my units. I go from number of atoms to mole of neon, according to my roadmap. Then I follow my units again, mole of neon to grams of neon. I got this value off my periodic table. I go to 2 decimal places. Then I do my math across the top, divide across the bottom, and you come out to 1.7 times 10 negative 13 grams of neon. So you have a worksheet to work on today. It should give you tons of practice. I hope this helps. And I will be back Monday of next week to help answer questions. So I hope this will serve you well. Thanks.